Hello, today we are going to do PTVN tables to try and determine the pressure, temperature, volume, or number of particles for different situations. The one we're looking at today is with an aerosol can. So it says on a hot 305 Kelvin day, so 305 Kelvin is a temperature, and we need to be in Kelvin because that is the only one that truly measures the movement of particles. 0 Kelvin means no movement, and every number positive after that is meaning some movement. So we have to use Kelvin whenever we're doing these types of tables. So you buy spray paint on this hot summer day, and the spray paint is initially at a pressure of 10.2 atm. So we write 10.2 atm here. Now you take that spray paint home with you, but you decide not to do anything with it. You decide to paint after it gets cooler. But sadly, you leave that can in your car, which is sitting in the sun. We all know on a Minnesota summer, that car can get pretty hot inside. And in fact, the temperature becomes 344, which is 160, which it can get to be that hot in your car, 160 Fahrenheit. This makes the can explode. We want to know what is that pressure right before it exploded, Now, the thing with the aerosol can is that it is a hard surface, and it is a non-flexible container. So there is no, volume is constant. We don't need to worry about volume. The other thing is it didn't say that we used the can at all. So we still have the same number of particles. So we need to figure out if temperature increased, which is what's happening here, temperature increased, what is the effect on pressure? So I like to draw my particle diagrams here. Because volume is a constant, we're going to draw these two boxes the same. This is initial, this is final. The number of particles is the same, so we're just going to do 3 in each of these, and they should be relatively the same size. And then the temperature is increasing. It's getting hotter. So in our initial, we're going to make our arrows shorter than what our final arrows are going to look like. So in this one, in the final, we find that if we increase temp, because the arrows are longer, they're hitting the sides more often. They're also hitting the sides harder. So we find that our pressure is also going to go up. So we want pressure to go up. To make that happen, we're going to take 10.2 atm, and we're going to use our temperature right here, and we want this to go up. So we need to multiply by the bigger number and divide by the smaller number for temperature. These two are not equal to each other, but we are trying to form a ratio of them. Kelvin cancels because they're top and bottom. And so we're going to take 10.2 times 344. We're going to divide by 305, and we're going to get 11.5 atm. Now, if we look, that is bigger than 10.2. So it's true that it went up. So this is our little check. Yes, it did go up. And we are done.